Today we will discuss circles. First, we have to define circles. So, set of all points in a plane that is fixed distance from fixed point. Okay, this is the fixed point. Okay, this is the fixed distance, and these are the set of points. Okay, so on plane, the set of points from a fixed point at a fixed distance makes a circle, right? And this fixed point is called center of a circle. Next, the interior part, the inside part, this is called the interior part of circle. This is on the circle, right? So it is circle itself, and suppose here is point D. Okay, this is outside of the circle, so this is the exterior part of the circle. Radius, the distance between the center of the circle and any point on its edge, is called radius. This is the circle, this is the center, and from center, if you draw any line on the edge of circle, this part, and I'm naming it AB, this will be the radius. Okay, so there are so many radius on the circle like this. I'm naming them. There are so many. So BE, BD, AB and BC, these are radius. Next is chord, the line segment within the circle joining any two points on the circle, right? Look at this. Suppose this is the circle and this is the center, but the line segment means here. Chord means this one, joining the 2 points on the circle without crossing or passing on to this center part of the circle, right? This is the chord. So I'm naming it, suppose A and B, right? This is also a chord because it is not passing through center point like C and D. Okay, next is diameter. A chord passing through the center of circle is called the diameter, right? Look at this. This is the center and I'm crossing the line from one point of a circle, crossing the center and to the opposite side of this point. This is called, I'm naming this AB and this O. So now this AB is your diameter, OB and OA, these are your radius. Okay, so diameter is 2 times the radius. Okay. Next is arc. The portion of circle between 2 points is called an arc. The curved part, that means this one. If I am naming this point A and this point B, so AB is your arc, right? Now look at this. This is the minor arc because the length is shorter than this part, so this is the longer part. This is the major arc and this is the minor arc. Next is circumference. The perimeter of circle is distance covered by going around the boundary once. Look at this. This is, suppose I am starting from this point and the distance covered from this point and to this point. So this is the perimeter, right? So it is also known as the circumference, right? So how would you calculate the circumference of circle? You have to apply the formula, that is 2 pi r. Pi value is fixed, 22/7. Radius will be given to you. Okay, next is segment and sector. A circular segment is a region of a circle which is cut off from rest of circle by a secant or chord. Look at this. This is the center. This is chord A and B. But look at this. The curved part is this curved AB part is your minor arc, and this line segment AB is your minor segment. AB is your chord, and this shaded portion, this shaded portion is your segment. Right now, this shaded part, the yellow shaded part, this is also your segment, but this will be your major segment. The larger part and the smaller part, this will be your minor segment. So what is segment? Region of circle which is cut off from the rest of circle by a secant or a chord. This one. Okay. Now sector. Sector means a portion of a circle enclosed by two radii and an arc. That means two radii. I am making here two radius, naming it OA and OB. Now an arc is AB. Now from this center part, this shaded part, this is your sector. Now similarly, look at this. The green shaded part, this is called your major sector, and this is your the black part, this is your minor sector. Theorem of Now we will discuss the theorems of circle. So to prove the theorem of circle, we have to prove that two triangles are congruent, and congruent means equal. Congruent means equal. This is the sign of congruency, right? And two triangles will be equal if their corresponding sides and corresponding angles are equal. So we have to prove that two triangles are congruent, and to prove these two triangles equal, we have to meet three conditions, right? So if we have met three conditions, then we can say that these two triangles are congruent, right? Now the first theorem of circle is theorem of equal chords subtending angles at the center. That means equal chords subtend equal angles at the center, right? So question has been given that equal chords, that means AB and CD is equal. The question is saying AB and CD is equal, and we have to prove that if chords are equal, then angles will also be equal at the center. So these two angles are equal, we have to prove this, and the sides are given, the chords are equal, that has been given here. Now we have to meet three conditions. We are taking these two triangles AOB and COD. Now look at this, AO and OD, these two are radius of circle, and radius of same circle will be same. The length of the radius of same circle will always be same, so the length of AO will be equal to OD radius. Again OB and OC is also radius, so OB and OC is also equal. Two conditions are met, and third condition is given to you in the question, that equal chords, that means AB and CD are equal, right? So we had to meet three conditions. We have completed here three conditions. Now we can say that these two triangles are equal. Now They are congruent. These two triangles are congruent by which rule? SSS rule. Side, side, side. Okay. Now, if we have met these three conditions, we can say that these two triangles are equal. Now, if we have proved that these two triangles are congruent, we can say that their corresponding parts will also be equal, since we have proved here, right? So we can say now angle AOB will be equal to angle COD by CPCT, corresponding parts of corresponding triangles. Now, if the angle subtended by chord of circle at the center are equal, then the chords are equal. Now, the question is, these two angles are equal. It is given to you, and now you have to prove that this AB will be equal to this CD. The chords are equal, you have to prove, and you have been given that these angles are equal. Now we'll apply same radius. Look at this, AO and OD. We will take these two triangles to prove the congruency. Now AO and OD will be equal because they are the radius. Next, OB and OC will be equal, right? They are the radius. Now angle AOB and angle COD, these two angles are given to you. Angle. Now we have proved three things here. Now we can say these two triangles will be equal. So by which rule? Look at this, S side, A angle, and this side. So side, angle, side. We have to prove it, the congruency triangle. So this is side, angle, side rule. Now we have proved these two triangles are equal by SAS. Now we can say that AB and CD will be equal by CPCT. Once you have proved the corresponding parts of once you have proved the congruency of two triangles, then you can say the corresponding parts means the corresponding sides and corresponding angles of two triangle will be equal. Okay, next is perpendicular. Perpendicular from the center to a chord bisect the chord. This means you have to prove here perpendicular from the center, as you can see, of a circle to chord bisect the chord. That means if I am making here perpendicular line, that means this perpendicular line through the center is dividing this chord into two equal parts. That means AM will be equal to MB. Here you have to prove. Now first we will prove the congruency of these two triangles, and then by CPCT we can say AM will be equal to MB. Right? Now I am taking these two triangles OMB and OMB, OMB and OMA. Right? Now look at this, OA and OB. OA and OB are the radius. The radius of circle will be same, so they have the same length. Next, OM is the side which is common to both triangle. That means the length of the side will also be same. So OM will be equal to OM. Next, now look at this. The question says perpendicular from center. Perpendicular from center means it is making 90 degree, right? So that means this angle is also 90 degree. This angle is also 90 degree. So angle OMA and OMB is equal to 90 degree. Right? We had to give three things to prove the congruency of two triangle, and we have given these three things. Now these two triangles are equal, these two triangles are congruent by Which property? RHS, right? Here the perpendicular part. Okay, therefore by CPCT, once you have proved the congruency of two triangle, by CPCT you can say corresponding sides and corresponding angles will be equal. We had to prove the chord bisect the chord,